Okay, folks, we're about to start the layout of the actual push paddles that are on the axle of the pendulum. Now we've done the wheel with the paddles on it, that the power wheel for the verg and foliot escapement. What we've done is, so that you folks at home can see a little better, I've transposed it on paper. Excuse all the smudges, my hands are dirty. I've been working all day on this thing. But anyway, we've transposed it on paper, and the black circle is it. The black lines are your 5 divisions. That's where your paddle wheels will go. Now, this, of course, turns this way, and these paddle wheels will come across and push on the push bar of the axle, on the axle of the pendulum. Now what we have to do is determine how much throw we want. I picked roughly 1.5 inches. Now if you take 1.5 inches throw to the center, what you're going to have here is 3 inches of throw total. Okay, so anyway, it's going to come off here. But now if you're building one of these things at home, just about anything will work. I mean, you can have fun, but I'm not. I'm not doing this for just a play project. I'm trying to build it as accurate as possible, because this is how I intend to measure, actually measure the absolute necessary power to power the pendulum itself. I've already know how to figure up how much output the TSO, or two-stage oscillator, puts out. That's so simple it's pathetic. But measuring accurately with how much power is taken to drive the pendulum is very difficult. Electric motors, a lot of people think you can put an electric motor on it and just measure the wattage, but that is bull. You can't do it. It will not measure it accurate. Anybody knows anything about electric motors and stopping and starting any kind of a motor, and building speed and slowing down and stopping and building speed again, knows you cannot do this with electric motor and measure the input. It's impossible. Now what we've got here is, because I'm trying to make it as accurate as possible, I've got a 1.5 inch throw from this point. I don't know if you, hope you can see that. There is roughly 3/16 of an inch gap right here. That's where my drive is going to be right there, my paddle wheel, and it's going to be roughly 1/4 to 3/16 of an inch wide, like so. Same thing on the other side over here. Now it'll be at this point, and that gap right there, because our paddle wheel has a thickness of 1/8 of an inch. That allows it to come, as it moves a 1/16 here, it's going to move a 1/16 over here, which gives us, actually there's 3/16 here and 3/16 here, is 3/8, and we're going to be using a 1/8 to 3/16 paddle wheel, which that one will be right here. Like so. Now your paddle wheel over here, it'll be on this side coming in. Over here it'll be on the back side going out. So as you can see, as it comes off, this one starts on, and that going to 1.5 inch throw, but yet coming out where the 1.5 inch throw actually hits right about here, but we come out a little further, so we actually have 1 inch and 9/16 to 5/8 on both sides, and that what that does is that gives us the that clearance for the thickness of the paddle wheel. I'm going to make this really short. Okay, on the actual layout of the axle paddle wheel, or power bar, whatever you want to call it, we wanted a 1.5 inch throw from outside to center, which would be a total of 3 inches. Now what we've done here is we've laid out a 3-inch wide piece of metal just to make it simple and so you can see it better. I've done a 1-inch axle. Now with the 1-inch axle, that's what we're going to use on the larger TSO with a 600-pound pendulum outside. So I'm just doing this so that you'll see what's going on. You can actually see it a lot better. We've done the axle, we've done the center, the hole for the axle. Now we need meat going around this axle to actually have the strength to hold the pendulum up and the force it's going to supply. So we come out with another 1/2 inch of meat, and we draw that line strictly so we'll know where we can and cannot cut. Now at that point, we want an 1.5 inch throw, so anywhere outside this meat, from the meat out 1.5 inches, which would be to here. That's going to be our arc. So what we've done, we put this here, we measured out 1.5 inches out this way. We've done this and we made our arc. That cuts through our two sides of our metal. Now, we take a straight edge and we go from the center of the axle, because we want this arc to follow, perfect, the center of the axle. We want it really smooth. And we just draw a line out to where it touches the edge of the metal, and that is your cut point right there. Then you go from that point back to the top of the meat, and you cut back on an angle. Now the reason for that, okay, by cutting it that way, that comes around like so, like this. So when it's over here, it's actually like this. And as the power paddle on the power wheel comes across, if it stops for any reason, it's not a flat surface and binds up, the pendulum swings back, it comes back and actually pushes it back, keeping it from binding up. Now, when it throws this way, there's an arc here, so as the paddle wheel comes in, it hits that arc. Well, for example, if you throw it too much and it comes down, it hits that arc no matter how far it comes, until it comes all the way up like this, which is ridiculous. But anyway, it'll hit this side of this wheel, of this arc, and ride the arc without moving forward or backward. So then as the pendulum comes down, then it catches, of course the bar will be right here, just passing straight across like this. And it comes up and catches it and comes around and goes off. I hope y'all can see that. Now the thing is, it's better if we were to make this like 4-inch metal and come 1.5 inches, not 1.5 inches, but yeah, 1.5 inches from the side, and then let the other 2.5 over here. That way our arc would come around over here more, and it would guarantee that it would not bind up even if you threw it way over. The whole point is to keep it from binding up. Now, this edge right here, the flat surface right there, should be very highly polished, and I'm going to try something and see how well it works. I'm going to use Dan Rojas's idea, Dan Rojas and Denise Rojas from Green Power Science. I'm going to use his idea of cutting a arc or circle on a table saw. However, I'm going to have to use a carborundum blade, and in cutting it, grinding it, and cutting it around, it should, I'm hoping that it will polish and smooth the edge as it cuts. So, but we'll see. I'm pretty sure it will. And I'm also going to try to cut this with a carborundum blade as well, so that I have a smooth, polished edge right here. All right, I hope everybody understands that.